Okay, here's warm-up 9.1.1. I'm going to match these methods for solving or simplifying with these problems, okay? So I'm just going to start going through these four, and then I'll figure out which of the methods I'm using. So when you're multiplying two fractions together, then you just multiply straight across. Okay, so that's D here. I use each of these once in this, so I'll kind of cross them out as I go. So I'll put a D there. This is method D, okay? And then I'd still want to simplify 5 over 27. Nothing goes into 5 and 27, so I can't reduce that anymore. So that one is simplified. If we're adding two fractions together, then you need a common denominator. So I'm looking at the 9 and the 3 and thinking, hey, both 3 and 9 go into 9. So if I multiply the second fraction by 3 over 3, then I'm not really changing that fraction's value. I'm just changing its form because I'm multiplying it by 1. But I'll have a common denominator that's 9. So I'll have 5/9 plus, this would be 3x over 9. And now I can combine those since they have the same denominator into one fraction. Okay, and it's considered simpler. Now some people will reduce the 3 and the 9, but you can't do that because the 3 is part of this binomial. It's attached to that other term with a plus sign. If 3 were a factor of the numerator of the top of the fraction, then you could reduce it, but I can't factor out a 3 up here. So that's as far as I can go. Okay, so I needed a common denominator. Let's see. Rewrite with a common denominator and combine like terms. So that was method B there. Okay. When I've got two fractions that are equivalent or equal to each other, that means the cross products are going to be equal. There are other ways you could solve this, but that's my favorite way. So 9x then is going to equal 5 times 3. 9x is 15. And then I'll divide by 9 to solve this. Okay, so I've got 15/9. But let's go ahead and reduce that. Let me zoom out. I was off screen a little. So 3 goes into 15 and 9. So if I divide by 3 on top and bottom, I'll get 5/3 there. Okay. So I cross multiplied there. That is first method. There's only one left. So let's see if this is actually going to work with us. So I've got 3 fractions, and there are different ways to do this. I could write these all with a common denominator and then start adding them and working with it that way. But what I like to do is clear the fractions. So I'm going to clear the fractions by multiplying by the lowest common denominator. Okay, this one's going to take a little bit more work, so I'm kind of just making myself some room. So looking at the denominators here, I'm thinking if I was making a common denominator, 3x would be a good one because all 3 of these denominators would go into 3x. Okay, so now I'm going to multiply each fraction by 3x, and that should clear out the fractions. Okay, so I'll multiply this first. It's going to be cramped. That fraction by 3x. I'll multiply this one by 3x. And when, if you multiply by 3x, you're kind of multiplying by 3x over 1. So you're really just multiplying the numerators by 3x. Okay, and then I should be able to do some reducing. In this first fraction, I can cancel out the 3's. And then I'm just left with x times 5, or 5x. Okay, the second fraction, I can cancel out the x's. And then I'm just left with 3 times 3, which is 9. And then my last one, I can cancel out the 3 and the x, and that just leaves me with 2. And now I've got a much nicer equation to deal with, no fractions. So I'll solve for x. I'll subtract 9 from both sides. There's a lawnmower going outside, so hopefully you can't hear that on the video. Okay, so x is going to equal -7/5 then. Oh, and I forgot to identify this is going to be method C here, right? Okay. All right. Okay, so, oh shoot, I was off screen a little bit again. So there's my answer, -7/5. Okay. All right. On number 5 here, Bilbo and Frodo got different answers when asked to simplify this expression. Who is correct? So what Bilbo did is Bilbo saw the 6's and thought, oh, I can just do this. So this equals 2x. Frodo, however, first factored out a 2 out of the top, and then looking at the 2 and the 6, reduced the 2/6 to 1/3. Okay, so 1/3. Well, I just have 1 times x plus 3 on top. On bottom, I'd have a 3. Frodo is correct. Okay? So I'm trying to illustrate this common algebraic mistake here. You can't do this because you can only cancel or reduce factors. I can't factor a 6 out of the numerator, so I can't just reduce those. So this is wrong. Okay? So instead, Frodo factored the top, then you can reduce. So the 2 up here is a factor. It's of the top, not a it's not a term. You can't cancel terms out unless they're just single terms. Okay? All right. So who is correct? Well, that would be Frodo. All right, last problem. Fix Gollum's mistake simplifying this expression. So let's see. Gollum at first factors the bottom, can factor 2 out here. Okay, that looks okay. And then looks like he reduced the 2's, which you can do, but the x plus 2 is still in the denominator. So when I'm reducing those 2's, I'm really reducing this into 1 over 1. You don't need the 1 on bottom because I can see there's one group of x plus 2, but you do still need the 1 in the numerator. So I need to show that the x plus 2 is still in the denominator. So that's another common mistake that I see is when people reduce. Sometimes they just lose their numerator, but I still want to show that x plus 2 is down there. Okay? And that's it for this warm-up, and I'll see you next time.